problem is find the cosine half range series f of x is equal to x sin x in x greater than 0 less than pi. Deduce that 1 upon 1 into 3 minus 1 upon 3 into 5 plus 1 upon 5 into 7 minus so on is equal to pi minus 2 upon 4. So solution. So the given function f of x is equal to x into sine x. So this is a given function and they have given the range 0 to pi. So they have asked we need to find the cosine half range series. So we'll write down the cosine half range series in 0 comma pi is given by f of x is equal to a naught upon 2 plus summation n from 1 to infinity a n into cos of nx. So this is the cosine half range series. I will give equation number 1. So where the value of a naught is 2 upon pi 0 to pi f of x dx and a n value is 2 upon pi 0 to pi f of x into cos of nx dx. So these are the Fourier coefficients. We need to simplify one by one by using the function f of x is equal to x into sin x. So we'll apply now. So now we'll take first a naught value. So a naught is equal to 2 upon pi 0 to pi f of x value is x into sin x into dx. So for this we'll apply Bernoulli's rule or else by parts. So I will apply. So by Bernoulli's rule of integration, so which is nothing but a naught is equal to 2 upon pi bracket keep x as it is. So integration of sine is minus cos x, differentiation of x with respect to x is 1. Formula minus differentiation of x is 1. So this minus 1 you have to carry, you need to carry. Integration of cos is sin x upon 1. Differentiation of 1 is 0. We'll stop it and close with the limit 0 to pi. So here again if you apply x is equal to pi, it will become, so if you apply upper limit as x is equal to pi, sine of pi will become 0 and sine 0 is also 0. So both for upper and lower limit it will be 0. So therefore a naught is equal to 2 upon pi minus sign I will take outside x cos x limit from 0 to pi. So which is nothing but minus 2 upon pi, apply upper limit, pi into cos pi minus cos of 0. X is equal to 0 means 0 into cos of 0 is 1. So 0 into 1 is nothing but again 0 itself. So therefore a naught will become minus 2 upon pi into pi cos of pi is nothing but minus 1. This minus minus will become plus. So pi cancels. So minus minus plus. So a naught value will be 2. We got the value of a naught. Now we'll see what is an. So an is equal to 2 upon pi 0 to pi x sin x into cos of nx dx. So therefore an is equal to 2 upon pi 0 to pi x as it is. So sin x into, because we have three functions x, sin x and cos nx. So x will keep as it is. For these two terms we'll apply sin a into cos b formula. So we'll keep x as it is. So sin a into cos b, that is I will put a bracket 1 by 2 into sine of a plus b, that is x plus nx, minus sine of a minus b, that is sine of x minus nx into dx. So we'll simplify. 2 upon pi, we have not apply integration, first we are simplifying. 1 by 2 out, this 2 will come here, x into bracket sine of, so x plus nx, so I will take x common, it will become n plus 1 of x minus, so if I take common here, so it will become plus sign, n I will take plus minus sign I will take common from this, so it will become plus, so it will be sine of n minus 1, because it has 1 minus n, I want to n minus 1 means minus, and if you take common, that minus this minus will become plus, so therefore sine of n minus 1 into x into dx. Now for this we need to go for integration first. So 2 cancels, so an is equal to 1 upon pi, we'll separate it, integration 0 to pi, first term x into sine of n plus 1 of x dx, plus this x into second term, x into, I will say that it is also 0 to pi, x into sine of n minus 1 of x into dx. So two integrations, means two terms, I have separated the integral, so an is equal to 1 upon pi commonly, which is nothing but we'll need to apply Bernoulli's formula for both. So on applying, keep x as it is, integration of sine is minus cos of n plus 1 x divided by n plus 1, formula minus differentiation of x is 1, this minus 1 upon n plus 1 you carry, cos of n plus 1 of x integration, it is sine of n plus 1 x upon n plus 1. So this is the first integral, that is limit from 0 to pi, plus second one, second integral we need to, so again I'll put a bracket, so x into sine n minus 1 of x, that is keep x as it is, integration of sine is minus cos of n minus 1 x divided by n minus 1, formula minus differentiation of x is 1, this minus 1 upon n minus 1 will carry, integration of cos is what here, sine of n minus 1 x upon n minus 1, and close with the limit 0 to pi. So on simplification of these limits, now here if you apply upper limit, first term will get a result, but second term again it is sine term. So in this, if you apply upper limit sine of n plus 1 of pi, so this term will become again it will vanish, because sine of n plus 1 of pi will become 0, and if you apply lower limit sine of 0 is 0, so this will be vanished completely 0, and the here last term also will vanish 0. So left part is an is equal to 1 upon pi, so minus x into cos of n plus 1 of x divided by n plus 1, second vanish, plus into minus is minus x into cos of n minus 1 of x divided by n minus 1 with the limit 0 to pi. So we'll apply upper and lower limits here and we'll see what is the results. So an is equal to 1 upon pi, we'll apply upper limit minus pi cos of n plus 1 of pi divided by n plus 1 minus pi into cos of n minus 1 of pi divided by n minus pi. This is upper limit, minus if you apply lower limit. So lower limit we have both the term having x, so 0 x will be replaced by 0 into this entire will be 0, this also 0, so therefore I will write lower limit will be 0 completely. So on final simplification, so this pi will take outside common, so it will become pi commonly. So an is equal to pi upon pi. Now it will be minus cos of n plus 1 of pi divided by n plus 1 minus pi we have taken outside, cos of n minus 1 of pi divided by n minus pi. Or you can take this one as there is a small correction here, so this is actually plus sign, and if you take a rearrangement this will become minus sign. So this will be minus, so here now on taking minus minus it will become plus sign. So this corrections, so on rearrangement finally pi pi cancels, an will become positive term first, that is cos of n minus 1 of pi divided by n minus 1 minus cos of n plus 1 of pi divided by n plus 1. So we got this has an value now. So here we can go small simplification. So as we know that cos of k pi can be written as minus 1 raised to k. Cos of n pi is nothing but minus 1 raised to n. Cos of k pi is equal to minus 1 raised to k. So therefore cos of n minus 1 pi can be written as minus 1 raised to n minus 1 divided by n minus 1 as it is, minus cos of n plus 1 of pi can be written as minus 1 raised to n plus 1 divided by n plus 1, or this can be written as minus 1 raised to n into minus 1 raised to minus 1 divided by n minus 1, second term minus 1 raised to n into 1 raised to 1 divided by n minus 1. So among these two terms, so minus 1 raised to n I will take common, minus 1 raised to 1 will take common. So minus 1 raised to minus is nothing but minus sign only. So minus 1 divided by n minus 1, and here 1 raised to 1 is 1, so minus 1 upon n minus 1. Sorry, this is n plus 1. So which is nothing but minus 1 raised to n. So it will become out here 1. If you take minus sign common also, or else I will take a LCM. So LCM is n minus 1, n plus 1. If you cross multiply, this will become minus n minus 1. If you cross multiply with this minus sign, so minus 1 minus so here just see this is we'll simplify once again. So an is equal to, I will write down these steps once again. So this will become minus 1 raised to n and minus 1 raised to minus 1. divided by n minus 1 minus, so this will be second term, minus 1 raised to n minus 1 raised to 1 divided by n plus 1. So on simplification, an is equal to, so minus 1 raised to n minus 1 raised to n will take outside. So what left inside, minus 1 raised to minus 1 is nothing but minus only. So minus 1 upon n minus 1. So minus 1 raised to 1 is nothing but minus. That minus and this minus will become plus 1 upon n plus 1. So on taking LCM and simplification, so LCM is n minus 1 n plus 1. So if you cross multiply, we'll get minus 1 minus n minus 1. If you cross multiply this, so plus n minus 1. So minus plus n cancel. Minus 1 will become minus 2. So an is equal to minus 2 into minus 1 raised to n divided by a plus b, a minus b formula. So it will become n square minus 1. Or I can rewrite this one, this minus 2 into minus 1 into minus 1 raised to n divided by n square minus 1, which is nothing but, so an value is, an is equal to, so 2 into minus 1 raised to n plus 1 divided by n square minus 1. So this is the value, but condition apply here, what here, where n should not equal to 1. Now we shall now find, if n is equal to 1, what happens, we'll find here. We'll find n when n is equal to 1. This is the value for when n is not equal to 1. If n is equal to 1, so this will vanish, okay, because 1 minus 1 is 0, value upon 0 is infinity. So therefore if when n is equal to 1, what happens, we'll see. So we'll go back to our an formula. That is, an is nothing but, we know that it is 2 upon pi 0 to pi x sine x into cos of nx dx. This is our an formula. Here if you apply the value of n is equal to 1, you cannot apply here, you need to go in the actual formula of an. So if you apply n is equal to 1, so we'll get the value of a1. N will be 1 means a1 2 upon pi 0 to pi x into sine x into cos of 1x means cos of x dx. So which is nothing but, so this 2 I will push inside, or else do one thing. So 2 upon pi 0 to pi x into x sine x cos x can be written as what here, sine of 2x divided by 2, because we know that sine 2x is nothing but, it is 2 times sine x into cos x. Sine 2x formula is what here, this sine 2x is nothing but 2 times sine x into cos 2x, or if sine x cos x is nothing but sine 2x upon 2. So this 2 into outside to get cancelled, we'll get it as a1 is equal to 1 upon pi 0 to pi x into sine of 2x dx. So if you simplify this, on simplification, on applying integration, so a1 will become here answer minus 1 upon 2. So on simplification, if you integrate this with the limit 0 to pi, we'll get minus 1 upon 2 here. So therefore the equation 1 becomes fx is equal to a naught value. So we know that our a naught value is 2 upon 2, because divided by a naught upon 2 means a naught value is 2 upon 2 plus summation n from 1 to infinity. So here we need to write first a1 value, then an. So I will write down here first an into cos of nx, so which can be written as 1 minus, so here we got the value of a1 means, so we need to write first a1 value, that is minus 1 by 2 of cos of x, because n value is 1, plus next value, what here, it will be plus summation. So n is equal to 1 already we have taken, it will start from 2 to z infinity. A n value, what answer we got as a n is, it is nothing but 2 times minus 1 raised to n plus 1 into cos of nx divided by n square minus 1. This is our f of x, or I can say that it is nothing but, f of x is nothing but what here, x into sin x is equal to 1 minus 1 by 2 times cos of x into summation n from 2 to infinity 2 into minus 1 raised to n plus 1 cos of nx divided by n square minus 1. So this is a required cosine transform of the cosine series of the given function. So in this expression we'll put x is equal to pi by 2 here. So we get the result is as, so pi by 2 into sine of pi by 2 is equal to 1 minus 1 by 2 into cos of pi by 2 plus summation n from 2 to infinity 2 into minus 1 raised to n plus 1 cos of n pi by 2 divided by n square minus 1. So therefore, but sin pi by 2 is 1 and cos pi by 2 is 0. So therefore here what happens, pi by 2 left hand side, so I will write down, since sin pi by 2 is 1 and cos pi by 2 is equal to 0. Okay, remember this basic result. So therefore this pi by 2 into sin pi by 2 is 1. So pi by 2 is equal to this 1 as it is, 1 minus 1 by 2 into cos pi by 2 is 0 plus summation n from 2 to infinity 2 into minus 1 raised to n plus 1 cos of n pi by 2 whole divided by n square minus 1. So now we'll apply. So this, you take 1 to the left hand side and apply, put n is equal to 2 onwards, 3 4 2 3 4 5 so on. So what happens, you take this one on right hand side, pi by 2 it plus 1 is there, it will become minus 1. So 1 by 2 into 0 it will vanish. So we'll get this 2, I will take common, bracket. If you put n is equal to 2, so 2 plus 1 is nothing but 3, minus 1 raised to 3, that is odd number, it's minus sign. So it will be minus cos of 2 pi by 2 divided by, it will be 2 square is 4, 4 minus 1 is 3 when n is equal to 2. When n is equal to 3, so minus 1, 3 plus 1 is 4, so positive value, so it will become plus cos of 3 pi by 2 divided by 3 square is 9, 9 minus 1 is 8. Next, if you put n is equal to 4, so 4 plus 1 is 5, odd number, minus sign. So cos of 4 pi by 2 divided by 4 square is 16, 16 minus 1 is 15. Next sign is plus sign, so on, which is nothing but, because here 2 cancels, cos pi, so cos of pi is minus 1, cos of 2 pi is minus 1 plus 1, but cos of 3 pi by 2 is 0. So here 2 cancel, so cos 2 pi is 1. So therefore, so on simplification, this left hand side will become what here? It will be pi minus 2 divided by 2, and this 2. So cos of pi is minus 1, that minus and this minus will become plus, so it will become 1 upon 1 into 3. Cos of 3 pi by 2, answer is 0, minus, so 2 ones are 2 twos are cos 2 pi is 1, so 1 divided by 15 can be written as what here? 3 into 5. So next expected number is plus minus plus sign, 1 upon 1 into 3, 3 into 5, next is 5 into 7, series result, minus, next expected is what here? 1 3 5, so it will become 1 upon 7 into 3 5 7, next number 9, plus so on. So this 2 you cross multiply, so it will be 2 to the 4, so we'll get finally, so finally we'll get the answer as pi minus 2 upon 4 is equal to 1 in divided by 1 into 3 minus 1 divided by 3 into 5 plus 1 divided by 5 into 7 minus so on. So this is the required solution.